Okay, an object is tossed straight up with a certain initial velocity and is 4 feet above the ground when it is released. So this is just a question taken from standard physics class, except that I've changed the exponent in order to force the students to use calculus rather than the vertex trick that I normally encourage. This 15 feet per second is right here. You don't need to know that, but if you're a physics student, you would. And the 4 feet above ground is right here. And again, this is physics. So you don't have to take the question and convert it into formula. The formula is given and the word problem is given. So now what do? We want to find the max. How high does it go? It's just asking for the max. So it just means maximize y. That's all it means. Or find the max of y. So you take the derivative. Yes, minus 16 times 2.1 t to the 1.1 plus 15, and so this is equal to minus 33.6 t to the 1.1 plus 15. Set equal to 0 to find x for max y. Okay, you're finding the single critical point. So you have 15, so you just take this piece and put it on the other side if you want to think of it that way. 15 is 33.6 t to the 1.1, and then 15 over 33.6, which happens to be 0.446, is equal to t to the 1.1. So if you found yourself at this point, or if a student finds themselves right there in the problem, that's not so bad, but the t is not 0.446, and so some people will get stuck here. So the thing you need to do is you need to raise both things to the same power. So the important thing to know is t to the 1.1 to what equals t? Well, it's 1 over 1.1, whatever that is. So you simply just take out your calculator and go 1 divided by 1.1, and you find that the magic number is going to be 0.9090 whatever. Okay? So something like that. Right? So we raise both sides to the 0.9091. So we have 0.446 to the 0.9091 is equal to t to the 1.1 to the power of 0.9091, which is the same as t. And let's make sure that works. 0.446 to the power of 0.9091 equals, let's say 0.48. Okay, so we say t is equal to 0.48. Again, I would spread this out, but I don't want to lose all my work. Oh, let me see. I could slide this a little bit maybe. I'm having trouble controlling this particular file because it's so large and it's so sensitive to my adjustments. Okay, so there's my t value. Now I'm going to plug this in. Y at 0.48. So now you can't see the function. Oh no, you can still see the function. 0.48 to the 2.1 plus 15. 0.48 plus 4. And you may be asking, do I have to write all that out? Well, no, you don't. But if you don't, and you get it wrong, you could lose credit. And if you write it all out, and then somehow you manage to invert some digits or calculate this incorrectly, I'll be a lot more forgiving if you've shown work. So it's to your benefit to show work as an insurance policy against stupid errors. Okay?